Application of VBT, valence bond theory, for octahedral complexes. Let's take the second example, COF6 3-. According to valence bond theory, first we should write electronic configuration of cobalt in its oxidation state. The charge on fluorine here is -1. 6 fluorine accounts for -6 charge. As the overall charge is -3, therefore cobalt here must be exhibiting a charge of +3. Hence, we need to write down first electronic configuration of cobalt in +3 oxidation state. Cobalt has an atomic number of 27. If 3 electrons are lost, then number of electrons present are 24. If we start with argon, it accounts for 18 electrons. Next comes 3D and 4s. And if required, we can also use 4p. Filling the electrons according to Hund's rule, 24 electrons, 18 are accounted for by argon, so 6 electrons, each occupying singly before pairing occurs. Now, let's consider the type of ligand that fluorine is. Fluorine here, fluoride ion, is a weak ligand. It cannot push the electrons like ammonia ligand in the previous example. Because of this, Hund's rule is obeyed, and hence the electronic configuration remains as such. Therefore, the 6 fluoride ligands need to find more orbitals, because here we have only 4 empty orbitals. Let's also write the next subshell, which is 4d. Now we can see that we have 6 orbitals, 1, 2, 3, 4, 5 and 6. Let's write these orbitals once again. Argon, these are the 3d orbitals which are untouched during this hybridization. One s, 3p and 2d orbitals, that is sp3 d2 hybridization takes place here. This is very different from the previous hybridization we saw in CONH363+, where we had d2sp3 hybridization. Therein 3d subshell was used. Here sp3d2 hybridization is occurring, wherein 4d subshell is used. After this hybridization takes place, electrons from fluoride ligand are accepted. Again, we can show them as crosses or stars. 6 fluoride donating 6 electron pair, occupying all the hybrid orbitals. So this is electronic configuration of the complex. This time we see that we have unpaired electrons. Here in 3d subshell, we can see there are 4 unpaired electrons, because of which this complex is paramagnetic. Due to presence of 4 unpaired electrons. The geometry of this complex is also octahedral, because here also we have sp3d2 hybridization, that is 1, 2, 3, 4 and 5, 6 hybrid orbitals, 6 coordination number, and therefore the geometry here is octahedral. The magnetic property is paramagnetic. The hybridization is sp3d2 hybridization.